All right, we're on page 7 of notes 12 of Calc C, and we're actually going to talk about something pretty unrelated, but very kind of related to the next thing. So take that for what it's worth. We're going to talk about Newton's method of approximating the roots of a function. And so to do this, to illustrate it, I think what I'm going to do is switch over to GeoGebra at first, kind of go through it, and then this is actually the second time that I'm making this video because I got wrecked by the calculator trying to make a spreadsheet for this. So I'm not going to do that again because I didn't take time in between to work out how I would do it. But maybe in another video when I get time, which I think in like 60 hours more of recording videos, I'll probably have more time. So let's see. So I'm going to go to classic and wait. And here we go. All right. So I want to graph a function. So I worked out ahead of time that like 1/10 x cubed plus 2 is like kind of a good function to work with. So this is our function, and what we're going to try to do is approximate that, the x-intercept, the 0, the root. So what I'm going to do is I'm going to first guess the root. I'm going to guess that the root is -2, and you can visually see that I'm way, way off, but I'm going to just put a point at -2. And then, so here's the weird thing. So you guess that the root is -2, and you're like, that's probably wrong. So then what you do is you say, well, what if, and I don't know like what makes you say what if here, but what if I put a tangent line on the curve at -2? So -2 is my guess. I'm going to go up to the function, and I'm going to do the tangent line between at that point. So -2 is my initial guess, but I'm like, that's not right. So I'm like, well, what if I make a tangent line? So I make a tangent line. Now I'm going to say my new guess is just going to be the x-intercept of this tangent line. So I'm going to all the way through this just use some built-in things. So I can intersect. The name of the tangent line is G and the x-axis. And it gives me the point B. Okay, so now here's where it starts getting kind of interesting. I'm going to say that's not really good enough. I want to get closer. How can I potentially get closer? I'm going to find the point on the function that is at the same, okay, so that I kind of fixed a problem that I was having with reminders, but not actually. I'm going to find the point on the function. So, and I'm going to do this a weird way. I'm doing it this way so that I can kind of like duplicate and not have to type this every time. So I go down vertically to the function, or I go up vertically to the function, whichever. I have a new point. What do you think I'm going to do? I'm going to write the tangent line at that point, but now I can start duplicating. So I'm going to duplicate this, and the point I want to use is C. And you can see it's pretty close. Let me pinch and zoom here. It's like really close. So the x-intercept of this tangent line is what I want now. So I will find the intersection, but the line is named H. And you can see that's like pretty close. But if I'm thinking that's not close enough, I'll do it again. So what I'm going to do is, let me zoom in. I'm going to drop to the function. So same x coordinate, but drop down to the function. And I can do that by duplicating this and using the point D. So this is what we want to do kind of by hand, but we're obviously going to use a computer. So now tangent line. So duplicate tangent E. Look at that. I mean, that's like really, really close. So let's find the intersection. Duplicate. So we're really finding the x-intercept here when we find this intersection. -2.71. All right. So, and then now the question becomes like, when do you stop? I mean, geez, I think you could probably stop here and say that it's, you can see it's wrong, right? But like, how much is it wrong by, and how willing are you to be wrong? So maybe your thought is, I'll keep going until 2 decimal places match, right? So my previous guess had been -2.74, now -2.71. So I don't know. Let's see what happens. So I'll duplicate. I need the point to be F. And this is something like, it's a sequence of events, right? It's iterative, so it seems like you should be able to come up with like an iterative process for this, and that's exactly what we're going to do. So let me see there, and then I have to duplicate the intersection. So that's our goal, is to iterate this so that we don't have to like do each individual step. So now you can see H and G have the same x coordinate. So I'm going to say that the x-intercept of this function is approximately -2.71. And I'm happy with that. Let's see if we can do the one that's in the notes. So that's the idea. It's start with a guess. Say that your guess is wrong, write the tangent line, find the x-intercept of the tangent line, that's your new guess. If you're happy with it, that's your approximation. If you are not happy with it, do it again. Find the point on the function, write the tangent line, and you go from there. So this is gonna be really annoying to do by hand. So like I'll do the first line here by hand. So my initial guess, which is x0, is -1. So I'm saying that if I set this equal to 0 and solve it, I'll get approximately -1. I mean, that's probably not really right, but it's close-ish, I guess. So what I'm really doing is, if I set this equal to 0, I get the cube root of -2. I'm trying to approximate the cube root of -2. I am going to need f prime, so f prime of x is 3x squared. All right, not a problem. All right, f of -1 is 1, f prime is 3. So the tangent line I'm going to write as y equals, and then 1 plus 3, x plus 1. And then I have to set that equal to 0. And that's going to give me x is, so subtract 1 divided by 3 is -1/3 minus 3/3 is -4/3. So this becomes my new estimate. So now I'm saying the cube root of -2 is approximately -4/3, which is probably wrong. So what I want to do now, which it's definitely wrong. I want to find f of -4/3. I want to find f prime of -4/3. I want my tangent line, which will be f of 4/3 plus f prime of -4/3, and then x plus 4/3. And then I'm going to set that equal to 0. And I'm going to try to solve it, right? So when I do that, what do I get? I get x equals, so I'm solving this. So I move f of 4/3, f of, what is it, -4/3? Or yeah, -4/3. You should be negative. I'm going to move that over, so I get negative f of 4/3. I'm going to divide by f prime, and then I'm going to subtract 4/3. Basically add -4/3 to both sides. So I'll end up with -4/3 and then minus f of -4/3 over f prime of -4/3. And let's say, so that's going to be, that's actually going to become x sub 2, right? So this is x sub 2 equals x sub 2. So then what am I going to do? Well, whatever I got here, I'm just going to say is x sub 2. So I'm going to find f of x sub 2. I'm going to find f prime of x sub 2. And I said I was going to do this on a calculator, but I decided not to. F of x sub 2 plus f prime of x sub 2, x minus x sub 2, set it equal to 0, and then we have to solve, right? So we're going to get x. But what x are we really getting? We're really getting the next x, which is x sub 3. So x sub 3 is going to be, you're going to subtract f of x sub 2, divide by f prime, add x sub 2. So it's x sub 2 minus f of x sub 2 over f prime of x sub 2. And then do you see how this has a specific form that's kind of developing? Like this. This whole part, I don't know what I'm doing. I got this potentially. This all could have been written as x1. Okay, hold on. Yeah. Okay. So it could have been written as x1 minus f of x1, f prime of x1, and that's it, right? So if I want x3, x4 rather, when I want x4, it's going to be x3 minus f of x3, f prime of x3. And if I want f10, I need to know x9, which means I need x8, and so on and so forth. Let's see if we can like get it done. So that's actually the general idea. So to find a new one, you're always going to take the old one, subtract f of the old one, divide by f prime of the old one. So let's see if we can use a calculator to like make that happen. And then we'll cut this video. So it's just like a really neat thing, and it's iterative. And the next thing we really want to study is an iterative process. So I'm going to say f of x is x cubed plus 2. Fp of x is going to be 3x squared, or you can like let the calculator do the work. It's up to you. And so x0 is -1. And then what am I doing? I want to like set this up somehow. So like 0 is going to be -1. All right, well, hold. I want to like set up a thing where I can like use a counter. So 0 is just -1. Okay, I'm gonna press enter. And then I'm gonna do the answer, the first part of the answer. Well, we will see if this works. Let me actually just do this. Answer like 2 plus 3. So this should give me 0 and -1 plus 3. So it should give me 0, 2, which it does. Okay. Now let's do it for real. So I want answer 1. So the first part of the answer I want to add 1 to, and then I want the second part of the answer, which is like my initial guess. So that's that. And then I want to subtract f of that answer and divided by fp of that answer. So I'm setting this up so I can just keep hitting enter and it will keep generating them. And I'm going to hit control enter here so that it's going to give me decimals all the way through. There's my -4/3. Okay, I'm just going to go for it, right? Okay, so I went a little too far. -1.25992 seems to have settled down, like actually really quickly. So quickly that it makes me feel like it might be wrong. Holy cow. I mean, it definitely like gave a, I don't know. All right, so we were approximating the cube root of -2. So if I do -2 to the 1/3 and get a decimal, -1.25992. That's it. That's all we were trying to do is iterate the process of finding the x-intercepts of tangent lines. That's Newton's method. I'm gonna go back to the notes. I hope this was sort of illuminating. Like, it's a really interesting concept. Full disclosure, not going to be on the BC exam. If you're in Calc 2 or Calc 1 even, you might have looked at this, and that's kind of neat. You don't need to memorize this or anything, but like the idea is really important because the next idea is also going to be about tangent lines. This was Newton's method. The next set of notes is all about Euler's method. So in the next video, we will be back and we'll be talking about that. So I will see you there.